All right, welcome. We're going to talk first about inverse functions. And let me hide this. So I've got a couple of functions for us to look at. So f of x and g of x. So first off, what happens if we take, for example, f of g of 5? Okay, f of g of 5, so we'll plug the 5 into this g machine. So g of 5 equals 5 plus 1. 5 plus 1 is 6 over 3. That's 2. So the output of g of 5 equals 2. So that equals f of 2. Okay, so let's plug a 2 into this guy. So we're going to get f of 2 equals 3 times 2, which is 6. 6 minus 1 is 5. So our output is 5. So we plugged in a 5 and got back a 5. Let's try the other way around. So let's do g of f of 5. G of f of 5. So let's see, we're going to plug in 5 into our f machine first. So plug in 5 in here. 3 times 5 is 15. 15 minus 1 is 14. So our output is 14. So g of 14. What happens if I put 14 into this guy? Plug in a 14 to my g machine here. So 14 plus 1 is 15. 15 over 3 is 5. Interesting. So in either case, we're getting back the same number. Let's go over to these pair here, h of x and j of x. So these two are a pair, and these two are a pair. Let's try h of x and j of x. Let's try the same thing, h of j of 5. h of j of 5. So we're going to plug in a 5 into our j machine, so 5 into here. So 5 minus 1 is 4. The square root of 4 is 2. So our output of our machine is 2. So h of 2. What is h of 2? Let's plug in 2 right here. So 2 squared is 4. 4 plus 1, 5 again. Interesting. Let's take j of h of 5. j of h of 5, so plug in a 5 here. 5 squared is 25. 25 plus 1 is 26. So j of 26. Well, what happened if I took j of 26? Plug in a 26 here. 26 minus 1 is 25. Square root of 25 is, you guessed it, 5. So interesting things are going on here. Basically, whatever I plug in, I'm getting the same thing back in any case. And that is true because these guys are inverses. F and G are inverses. F multiplies by 3, G divides by 3. F subtracts 1, G adds 1. Same thing over here. H of x squares x. J of x does the square root, opposite. H of x pluses 1 and J of x minuses 1. So whatever one does, the other one undoes it. Right? That is the definition of an inverse function. So inverse function, which we can call, we can write a little negative 1 here. It's not an exponent. Inverse functions, first off, they undo each other. They undo each other. So f of f inverse of x is just x. Likewise, f inverse of f of x is just x. So if you take the composition of functions, you're just going to get back the original. Another key feature, the domain of one is going to become the range of the other, and the range is going to become the domain. And another key feature, the graph, if you graph the original function and the inverse function, it's going to be a reflection over the line y equals x. So let me just demonstrate that over here briefly. Let's say we have a function, a relation. S is 1, 0, 2, 1, 3, 1. So 1 goes to 0, 1 goes to 0, 2 goes to 1, 2 goes to 1, and 3 goes to 1. All right, that's S, right, these 3 points. Now the inverse of S, to find that, remember the domain becomes the range, and the range becomes the domain. So x becomes y becomes x. Let's just flip these guys around. And let's see what we get when we graph that. So 0 goes to 1, 0 goes to 1, 1 goes to 2, let me add these guys here. 1 goes to 2, and 1 goes to 3. All right, so if you can kind of see here that these guys end up being a reflection of each other over the line y equals x. This is the line y equals x. Every time you have a function and its inverse, you're just going to reflect those points across this line to get your inverse. Now, another key thing you can see here is that the orange relation fails the vertical line test, right? One input gives you 2 outputs. So just because the original is a function, the inverse may or may not be a function. In this case, it is not a function. Finally, to find the inverse, you're just going to switch x and y and solve for y, and we'll practice some of those. But to end this video, let's just do some really simple problems based off of that first property. So let's find f of f inverse of 32. F of f inverse of 32. Well, since these are inverses, they're just going to undo each other. So whatever I plug into the beginning, I'm just going to get back. That's just 32. All right? Same thing the other way around. F inverse of f of negative 42. They're going to undo each other, and my output's just going to be negative 42. And finally, f inverse of f of y squared. Again, they undo each other. We just get y squared. So after this, we'll try some problems finding inverses and graphing, etc. But this is the basics.